All right, so in this video, we're going to stick with modeling equations here. We're modeling different situations. We're going to use similar triangles, okay? So in the first couple videos here, we talked about, we had consecutive integers problems, then we had some length, width, and area problems, and now we're dealing with similar triangles, okay? So a lot of different modeling problems that we can do here, all right? So here we've got a man who's 6 feet tall, walks by the same 7-story building every day. Okay, he's always wanted to know how tall that building is. One day, he decides he's going to measure the shadow of the building. He's going to measure his own shadow, and he's going to use that to determine how tall the building is. Okay, so he measures the building's shadow to 31.25 feet. Okay, he measures his own shadow to 2.5 feet. How could he find the height of the building with that given information? Okay. So first thing we want to do, we've got a building here, and we've got the shadow. So this will be the shadow that it casts, okay? So we know the height of the building is what we're trying to find, so we're going to call that x. And we know the length of the shadow is 31.25 feet, okay? We've got a 6-foot man here who casts a smaller shadow, a 2.5-foot shadow. So we know his height is 6 feet, and we know the shadow is 2.5 feet. Okay, so we've got similar triangles here. So if we were to connect the top corner of the building with the end of the shadow and connect the top of the man's head down here with the end of his shadow, we've created a triangular situation here. Okay, so we can set up a ratio and proportion here relating either the height of each object to each other and the length of the shadow to each other. There's a lot of different ways you could set up the ratio and proportion. But what I've decided to do is I've decided to compare the height of the object here, the height of the building, to the shadow it creates, okay? So when I'm setting up the next ratio, I have to be consistent with that. So here I did height to length of the shadow. So height divided by the length of the shadow. So I have to be consistent again and do that over here. So my ratio here would be 6 to 2.5, okay? So we can say x is to 31.25 as 6 is to 2.5, okay? So these two ratios have to be equal, all right? That's how we use similar triangles to solve problems like this, okay? So once you set up this proportion, we're gonna cross multiply, okay? So I'm gonna multiply x times 2.5. That gives me 2.5x. I'm gonna multiply 6 times 31.25. That gives me 187.5, okay? So that's gonna let me solve for x. I'm gonna divide both sides by 2.5, and that gives me the height of the building. X should be 75 feet, so we know the building is 75 feet tall, okay? Just to verify that, if you plug in 75 here, if you divide 75 by 31.25, you're gonna get the exact same thing as if you divide 6 by 2.5, okay? So that's how you can use similar triangles to do some problem solving here.